transplantation of hematopoietic cells.
Let's talk how to test if your drug induces a cytokine storm.
Welcome to JAX Tech Talk with the technical information scientists of the Jackson Laboratory.
Welcome to JAX Tech Talk with the technical information scientists of the Jackson Laboratory. My name is Som Shuvra, and my role as a technical information scientist is to serve the research community with in vivo research education solutions and offers answers to all your technical queries. For anyone watching live, use the comment section of this video to share all your questions wherever you're viewing from, and we'll try to answer those live. So today, in this ever-changing era of COVID-19 research, our topic is let's talk COVID-19 models and discuss the latest advancements in this field as of early 2022. Today, I have Caitlin on the show with me. First of all, Caitlin, could you please introduce yourself to our audience?
Sure, thank you, Som. So my name is Caitlin, and I'm a senior technical information scientist here at JAX. And my background is actually not in infectious disease models, but rather since the start of the pandemic, I, like a lot of others, have taken an interest in COVID-19 research and took on the role of learning the different available mouse models for researchers and the different abilities of those models. And so since then, I've given several talks at conferences as well as here at JAX, which actually reminds me, we posted some links down in the description that I think will be really useful for all of you who are viewing. The mouse genome informatics page, as well as some other resources, are available, and we'll give you some additional information on the topics that we're going to cover today. So like Som said, if you have questions, please submit those in the comments and we'll do our best to answer those live.
Right. So for all of you who are new today, we did a JTT addressing COVID last year. It was titled Let's Talk COVID Mouse Models, and it was done on March 2. We discussed several mouse models that can be utilized to investigate COVID-19 using in vivo studies. I would highly encourage all of you to revisit this talk when possible. But as a follow-up to that great discussion from last year, my first question to you today, Caitlin, is what do we know new about COVID-19 and mouse research? Do we have any new evidence that supports mice can get the disease?
Yes, so there have been a few publications that have come out since last year suggesting that mice can become infected with SARS-CoV-2. But there is a real major caveat to that statement. And that is that if you're wearing the proper PPE in your lab or facility, the transmission rate should be very, very low, next to nothing. Because this is the same PPE that you'd be wearing, like an N95 respirator, that you'd be wearing around someone if you were, let's say, a doctor in a hospital treating a patient with COVID-19. So like I said, there are a few papers out there. I believe they're still in preprint, which means they haven't been peer-reviewed yet. But like I said, there's that possibility, but as long as you're wearing the proper PPE, you really don't have anything to worry about.
Excellent information, Caitlin. I'd also like to supplement what you mentioned in terms of a question we get pretty often. Have mice been able to mimic long COVID efficiently? What is long COVID? CDC says that long COVID encompasses post-COVID conditions ranging from new, returning, or ongoing health problems that patients experience 4 or more weeks after first being infected with the virus that causes COVID-19. Even people who did not have COVID-19 symptoms in the first few days or weeks after they were infected can have long COVID symptoms. These conditions can present as different types and combinations of health problems for different lengths of time. How in vivo research can be utilized to learn more about these short and long-term health effects associated with COVID-19 and why it might be crucial in our understanding of these complications is what the question of the hour is. Currently, very few pieces of evidence exist that demonstrate how COVID-19 may sustain in a mouse model in a prolonged and sustained manner. There are no good mouse models for studying long COVID-19. Most of the research being done on mice ends up having the mouse either becoming sick very quickly or having an experience with severe outcomes early on. In several instances, most of these experiments are planned only to study acute responses, and hence the investigations get ended early. Hence, no one gets to look at the effects long term. Therefore, this opens up a new research need to design, study, and investigate mouse models that can be utilized to serve this very purpose of our understanding of long-term implications of COVID-19. These would also open doors to new questions and unravel our understanding of the disease. And with this, I would like to also remind all of the audience who are viewing today to submit your questions in the comment section. We'll be trying to get to all of them as much as we can as time permits. And that brings me to the next topic where we have been getting a lot of questions on. Is COVID-19 and brain research related? What do we know about mouse models of COVID-19 in terms of application in brain research? Caitlin, you being the brain researcher, do you want to address this?
Sure. So like you said, we do get a lot of questions about COVID-19 mouse models for brain research. And the first mouse model that we brought in is stock number 034899, in case you want to look that up. And that has the human ACE2 receptor that's expressed under the SYN1 promoter. And so this targets human ACE2 receptors to the nervous system. However, as a caveat for this strain, mouse ACE2 is still expressed throughout the mouse epithelial tissues. And sometimes that can be a problem for researchers because you don't know the effects of the mouse ACE2 in combination with the human ACE2. And so now we know that the SARS-CoV-2 virus can use the mouse ACE2 receptor for infection. You might have to deal with some confounding variables with this particular strain. So it's certainly possible to use that mouse model, but you need to be aware of those possible confounds. We do have a couple other options that are gaining a lot of popularity because of that previous caveat. One such model is strain 35,000. It is actually a strain where the mouse ACE2 receptor is knocked out and is replaced with human ACE2. Now, this model isn't necessarily specific to the brain. However, we do have a second strain where that human ACE2 is floxed. And so we can actually use a Cree mouse to breed with our human ACE2 floxed mouse, and we can knock out ACE2 in different tissue types. So maybe you want to knock out the ACE2 in the epithelial cells or ACE2 in some of the cells within the brain, and you can look at the different effects that the brain may or may not have on COVID-19 infection.
That is very informative, Caitlin. And coming to the next question that we always get beyond this is the housing conditions for these mouse models of COVID-19. At JAX, our models, as Caitlin just mentioned, the stock 034860, the K18HS2 mice are housed in standard conditions with basic enrichment. Now, the Jackson Laboratories mouse production facilities are all BSL-1 facilities. This includes where we house the strain 034860. Now, the transgene that is present in this mouse confers an increased susceptibility to viral infection-induced morbidity, mortality, and that's why we house it in a maximum barrier room. As these mice have been engineered to have increased susceptibility to viral infection, maintaining them in a lower barrier can sometimes result in mice becoming ill within the facility. Therefore, we recommend that researchers who are using these mice handle these mice wearing CDC-recommended COVID-19 personal protective equipment or PPEs. Details of these are listed on the CDC website. You can go online and check it. As for the health of the mice, I would recommend anyone planning to use these mice to speak to their facility veterinarian or animal care team about how to best house these mice. And that brings me to my next question to Caitlin, which is, what do we know about anything, or do you have anything else to add, Caitlin, to this?
Yeah, so we actually have some really exciting research coming out of JAX. One of our scientists, Nadia Rosenthal, is actually looking at how genetic background impacts SARS-CoV-2 infection. And so what she did was she took the 34860, the C57 Black 6J mouse with the HACE2 mutation, and crossed it with several different genetically inbred mouse strains and wanted to know if these mice would respond differently to SARS-CoV-2 infection. And what she and her colleagues found is that there is a difference in mice with different genetic backgrounds. So some mice actually become more resistant to infection. Some are very sensitive to infection. And there are some major sex differences between some of the strains. So, for example, in just the C57 Black 6J mouse with the HACE2, it's a lethal disease. We see manifestation of the virus in the respiratory system. But for example, when you cross the C57 Black 6J HACE2 mouse with, say, the PWK inbred mouse, these mice are asymptomatic. We also see when you cross the C57 Black 6J mouse with the WSB inbred strain, only the females are affected. So this could be a really great model going forward to look at the variability of infection and symptoms that we see in the human population. So I think keeping an eye on these crosses will be really important going forward in the future.
Right. So I see a few questions come up from our viewers today, Caitlin. There's a lot of questions coming, so I'm trying to keep track. The first question that comes to me in my screen is, how are mice typically infected with COVID-19? Are symptoms variable in mice similar to humans? You want to take that, Caitlin?
Yeah, absolutely. So we do see some variation depending on genetic background, like I just said. But if we're looking specifically in the 34860, that Black 6, C57 Black 6J genetic background, usually most of the mice succumb to the illness between 6 and 8 days, with the majority of the mice having a severe outcome by day 8. So we don't see tons of variability between or within the strain because, for example, the C57 Black 6J is all the mice are essentially genetically identical. And so that we don't see differences in those strains. But across strains, we could certainly see differences. And I think we'll see some more of that data coming out as more researchers publish their findings.
Right. That's very interesting. And I have a very good question from another viewer today that says, how long should one wait to examine long COVID affected mice after infection? Is 5 days enough? Maybe I'll briefly touch that. It's like the answer is very it would depend on the mouse model. And as we discussed earlier, that there is very few models right now to have a proper idea on what can be expected with to see the long COVID. I think the most important thing here is to have an established model first, do pilot experiments before coming to any conclusions, because we would need evidence to support this. Do you agree, Caitlin?
Yeah, absolutely. I do see another question that came in asking about how mice are typically infected with COVID-19 and are the symptoms variable in mice similar to humans? So I can touch on both of those questions. So the first one, to my knowledge, most mice are infected intranasally with a spray. I'm sure there are other ways that researchers are infecting mice, but it does have to, the SARS-CoV-2 virus does have to come in contact with those epithelial cells where the ACE2 receptor is. And then symptoms variable in mice similar to humans? Like I said, the symptoms are gonna be very similar within strains, especially the inbred strains, just because they're genetically identical. But as we start to look across different strains, I think we'll see some variability in symptoms, as we see with Nadia Rosenthal's work and crossing to different genetic backgrounds.
Right, and that's where Nadia's work will be very important, because it will actually open a lot of new information about how we know mouse model and this disease. So I see a new question here, Caitlin, that says, what respiratory symptoms are seen in mice and how do we quantify them to assess the disease severity? You want to take that?
Yeah, I think for the most part, a lot of researchers actually refer to body weight loss as sort of a indirect measure of illness for SARS-CoV-2. At least that's what I've seen the most of. So it's hard to quantify respiration in mice. It can be done. But from what I've seen, most of the time people are looking at a decrease in body weight as a way to assess disease severity.
Yeah, I also want to add to that depends on the model that you are planning to use.
That's true.
You will find a lot of information about the allele in that mouse in MGI or mouse genome informatics. A lot of these data and the phenotypes that are observed in these mouse models, a lot of researchers put the data in MGI, and it sometimes is a very good trend in this situation where you can go and see what other researchers have found in these mouse models and have published with them. That would give you a very strong evidence-based idea about what is expected in the mouse you're working with.
Yeah, and just to kind of piggyback on that before we wrap it up, I think keeping an eye on the MGI link for SARS-CoV-2 is going to be really important. That's where we're curating all of the most up-to-date information. So as things change, as we learn more, those publications will go there. The new mouse models will go there. So keeping tabs on that, I think, is the best way to really stay up to date in what's going on with SARS-CoV-2 and mouse models.
Yeah, excellent. So thanks, Caitlin. I think that's all the time we have today. This conversation was really informative and perhaps helpful for all of you to have a refurbished understanding of what is known about COVID-19 research in terms of using the mouse model in your investigations. Keep the questions coming in. I'm sorry we couldn't answer all of your questions today. We'll try to reach back to you one by one when we get your questions. We hope that some of the things that we discussed today would stimulate additional questions, which we would love to hear from you and discuss further. That's all the time we have again for this week. Thank you for joining us for JTT number 49 this week. Our next JAX Tech Talk is scheduled for February 15th. It is our 50th episode, so it's very special for us. It's been a long journey for us to reach to this episode 50, and we would not have been able to do it without all of you, our listeners. Please follow our JAX Tech Talk page on LinkedIn, where we keep on putting updates. Our videos are, we always put out our old videos so that if you have missed them, you can see them. And you will be notified anytime if you like our page, whenever we have a new episode. Or you can also subscribe our playlist in YouTube. We have a YouTube page also. This is Caitlin and Som signing off and wishing that all of you stay healthy, stay safe, and stay excited about research.